Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 57, I chat with Runco's chief product architect, Bob Williams, about the company's new 3D projector. So stay tuned.
Netcasts you love.
From people you trust. This is Twit.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded March 14th, 2011, episode 57. Runco goes 3D. Hey there, Scott Wilkinson here with UltimateAVMag.com and HomeTheater.com. Today's guest geek is Bob Williams, Chief Product Architect for Runco International. Hey, Bob, welcome to the show.
Hi, good to be here.
Thank you. Those of you who are tuned into the live video stream at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Bob, and I'll pass along as many as I can. Now, today we're going to be talking mostly about the Runco D73D, a unique 3D projector, which has a lot of very interesting features that I want to get into here with Bob. So, Bob, just give us an overview of the projector, if you would.
Well, the Runco D73D is a dual LED engine projector. It's designed to be able to support double the brightness of our typical LED projectors. And it can also do 3D with one projector representing your left eye and the other projector representing your right eye.
And there we see a picture of it. For those of you who are watching the video stream, we see a picture of it, and it in fact looks like two projectors stacked on top of each other.
Yes, and it is in our new industrial design, our Copenhagen industrial design, which is debuting with that projector.
Wasn't that also in your LED 2D projector, though?
No, our LED 2D projector still uses the classic design that we've had in the past. The one
okay. All right.
Affectionately called the tuxedo design.
So why is this called the Copenhagen design, I have to ask?
Well, it's based upon the inspirations from the Scandinavian design philosophies that we've had, and our industrial designers came up with that term to kind of coin the entire look of the product.
Of course, it makes me think of the Copenhagen interpretation to quantum mechanics, but I'm sure it has nothing to do with that.
I'm absolutely positive it has nothing to do with that. Yes.
Okay, so why did you take the dual projector approach as opposed to the single projector approach, which most other companies have taken? I mean, to 3D is what I mean.
Sure, I understand. So to actually talk about that, it's I guess I should go into the history of the product. Our original Q750, which is our LED projector, was well received. We had great reviews. It has very high contrast, very good colors. But one issue that it has is that it can't go on a really big screen because it's LED based, and LEDs at this stage in their history are a bit dimmer than mercury lamps. So what we did is we started out thinking, oh well, we can stack the projectors and create a double brightness LED projector. And it was right around that time when the 3D craze hit at CES. This was I guess early last year. And once we had the concept of having two LED projectors, we thought, well, wait a minute, this would be great for 3D too. So hence we now have a D73D, which is our dual projector, dual eye projector. So you have everything you need for a bright LED projector and everything you need for a 3D projector at the same time.
You also make a 2D LED projector that's stacked as well. Didn't I see that at CES this year?
Yeah, it actually looks identical to the D73D, and really it's really a processing difference only. The product is the same. It doesn't have the polarizers, the automatic polarizers on the front of the product, but other than that, it's essentially the same platform that the D73D is.
Now, Dave A. in the chat room asks, how large an image can they project and still stay lined up I assume the size of the image and the convergence or the lining up of the two images are not related, are they?
No, and in fact, if you're the farther away you are from the screen, the easier it is to line up the images because you have less offset required between the two projectors. So there's really, the only limitation is the total brightness. The light output itself wouldn't allow you to go above a certain size. And
so,
what size, it depends on how much gain you have in your screen.
So and we're going to talk about screens later because you need a special screen in this particular case with this projector.
Yes, that's correct. For any 3D implementation, you need a special screen. That's our argument already. So whether
even with active shutter glasses or Dolby 3D.
Yeah, well, the problem is because of the efficiency loss of either of those two techniques, you're going to get a new screen anyway. You're going to need a new screen just because you have, with shutter glasses you have about a 20% throughput, and with the Dolby type glasses you have about a 10% throughput. So
really, that low? I didn't realize that. I thought Dolby was a little higher.
Well, it depends what kind of lamp you're using. So. The Dolby implementation is really tuned for xenon lamps, which have a broad spectrum.
Yeah.
And the UHP lamps, which are used in the consumer projectors, generally have a very spiked response. So using the matrixed color technique to try to separate the colors out is very difficult with the spiked response because you're separating out a spike in the lamp, so you end up with a very low efficiency. And
I didn't realize that.
Yeah, and what happens is your efficiency in one eye is much less than the other eye, so you end up having to compensate for the deficient one, if you want.
Now wait a second. You mean one of my eyes is less efficient than the other, or are you talking about the two images coming off the two projectors?
When you use the Dolby system or the Infotech system, both of those are actually different. The way they band pass the colors. One eye ends up being less efficient than the other eye.
Oh, I see. I see what you're saying. Let's take a moment and go over the three basic types of 3D technology, or we should really say stereoscopic imagery, because I tend to think that 3D as a term, it's very convenient, it's shorthand, it's great for that, but it's not exactly the same as what we're talking about when we look at a 3D image on a movie screen or a TV screen. That's really what we should more technically correctly call stereoscopic imagery, right?
Yeah. In fact, using the term 3D, you're really doing only one thing when you're creating these alternate eye images. You're tricking your eye into thinking that into divergence required that would make the image appear closer or farther away, and that's the only thing you're doing. So in real 3D, there's lots more cues than that. But even within the whole concept of just tricking your eyes at different points of views, there are different technologies as well.
Right, and there are three basic technologies that are being used currently to simulate 3D using stereoscopic imagery. And really the basic premise is you need to make two different images, one for the left eye, one for the right eye, and then you need to isolate them so that your left eye sees only the left eye image and your right eye sees only the right eye image. And so there are three different ways to do that. Tell us about those three ways. Okay,
well, the way that typically is done at the lower end of projectors, for instance, would be to use what's known as frame sequential, and what they do is they use shutter glasses and a single projector, and the shutter glasses closes one eye and shows the image of the corresponding the other eye, which is open, and then quickly shows the opposite eye view, and does that at a high enough frame rate that it appears that the images are continuous.
And that's what's used for most flat panel TVs, certainly, as well as some projectors.
That's correct. Although some flat panel projectors use an interleaved technique also.
Right, which we'll get to in a second.
Right.
That's right. That's right. And that is, in fact, starting to get a little more press these days. since LG and Toshiba, I think, announced that they were going to start using that technique in their flat panels. But we're talking about projectors today, so let's stick with projectors. So we have active shutter glasses, which is one approach, or frame sequential, as you call it.
Right.
Then we have the Dolby system, which we were mentioning, and I'm saving the one you're using for last, in which the two images, well, you explain it to us.
Well, in the Dolby system, what they do is they take a portion of each color and allow that to go to each eye. So in a typical projector, you have red, green, and blue being projected simultaneously. And what they do is they take half of the blue and send it to one eye, and take half of the blue and send it to another eye, and the same for green and red. And
we should say here that when you say half of red to one eye and half of red to the other, and the same for green and blue and so on, that really red, green, and blue are not a single wavelength, but rather a band of wavelengths. So I think what you're saying is that they take, say, the longer red wavelengths and send them to one eye, and the shorter red wavelengths and send them to the other eye, and the similar thing with green and blue.
Right, that's correct. So essentially, they have to create a 6-color system instead of a 3-color system, and what that amounts to is creating these very fine bandpass filters for the colors that only allow a certain up to a certain frequency of green to go to for the green in one eye, and then after that, the rest of the green goes to the other eye. So it's very complex. It's actually more complicated at the projector side than at the glasses side. So the glasses can be made cheaper than the filters in the projectors. But still, it's relatively expensive to do. It uses what are known as dichroics, which reflect the light that isn't supposed to go back into the system. So there are some issues associated with that. For instance, you generally have to have shades over the eyes. Otherwise, you'll see a reflection of your eyes in the glasses, because unlike polarized systems, it reflects back any light that it's not sending through.
Wow, I don't remember ever seeing that. I've seen several presentations in Dolby 3D, but I don't remember ever seeing that.
Well, next time, I mean, we try to hide
I'll watch
the
out for it next time,
I mean, the best technology use is when people don't notice things. So,
of course.
But as an engineer, I have to know all this stuff in order to make clear decisions about what technology to use. That's not to say that that it doesn't work well. It's just that there are some issues that with the 6-color system like Dolby and Infotech that do not exist for the absorptive systems like the polarizer.
Right, which is now our third type of stereoscopic imagery, and the type that you have selected for the D73D. So run us through the basics of that.
Okay, so the way we do the separation of the eyes is we run 2 continuous projectors, one for each eye. And in front of each projector, we have a polarizer, a linear polarizer typically, although we do also have circular polarizers available for those who want them. But a linear polarizer, which takes, they're essentially in light, in random light, you have equal amounts of 2 polarizations that are 90 degrees to each other. And what you do is you essentially filter that in front of the projector so that you're only filtering all of the polarization that's going in one direction for one eye, and all the polarization is going 90 degrees to the other eye.
And we should say, just for those who might not be familiar with this, that light being an electromagnetic wave, it's a wave, and so the polarization is the direction in which the wave is vibrating.
That's right, yes.
And so we can talk about vertical polarization, in which the wave is vibrating up and down vertically, and we can talk about horizontal polarization, in which the wave is vibrating horizontally back and forth. And so what you're saying is and in general, in light, generally, just coming from the sun or a light bulb or an LED or whatever, that polarization is random. And you're saying you put a filter in front so that only vertical polarized photons of light come through for one projector, and only horizontally polarized photons of light come through for the other projector.
That's right. And once you add those two together, you end up with 100% of the light. So it's not that you're only limiting to a very small amount of light. It's anything that has any vector that's vertical goes through one, and any one that and any light that has a vector that's horizontal goes through the other one. So you're not.
Right.
It's not a small amount of light you're letting through. In fact, the efficiency is about through polarizers, the best polarizers these days, like the ones we have in our projectors, is about 80% of the light of any given polarization goes through it. So that efficiency is very good for something like that.
So you are, though, losing 20% of the light coming from the light engine as it passes through the polarizer and heads on towards the screen.
That's right.
Okay, and then it gets reflected from the screen and passes through polarizers in the glasses, polarizing filters in the glasses.
Yep. And then you lose another 20% also there. So you end up with a total of about 70%, something like that, 68% of your light.
Well, if you're losing 20% outgoing and 20% incoming, that would seem to me you're getting 60% of the light that originated in the LED.
Okay.
It's still a lot more than shutter glasses or Dolby 3D, or Dolby or Infotank.
Right. And what can happen with our system is you can essentially use one screen for both 3D and 2D because you have 60% of the light of a single projector when you run both projectors simultaneously. So you can essentially not have to optimize your screen for the brightness of 3D or 2D. You can just pick one.
Now, wait a second. You said you can use the same screen for 3D and 2D.
Yes.
But in the case of the polarizing system, which is what you are using in the Runco, you need a special polarization preserving screen, right?
That's correct. You do.
And which is a silver screen. It looks almost, it's not a mirror exactly, but it does have a definite silver color to it. Now, I've always believed that such a screen was not ideal for 2D viewing. In particular, it's got a very high gain and a relatively narrow viewing, thus a relatively narrow viewing angle, and problems with hot spotting and so on like that. I mean, I think, if I'm not mistaken, the screen you guys were using at CES or CEDIA, I can't remember where, was one from Korea with a gain of 10, for heaven's sakes.
Yes, it did. And no one complained about hotspots.
Well, so, looking at the 3D material, maybe not. But what about looking at 2D material? We didn't see any of those during the demo.
There's no difference between 2D and 3D for hotspotting.
Really?
Why would there be any difference?
Well, I can't think of a reason now that you mention it.
So, when people say that, I agree that sometimes you want to make compromises to get the fad thing, the 3D, I suppose, where you can say, oh, it's okay if it hotspots for 3D, but it's not okay if it hotspots for 2D. But I don't take that opinion myself. I think it shouldn't hotspot in either case. And, the reason that people didn't complain about hotspotting for our 10-gain screen that we used at CEDIA, and by the way, it's a 12-foot wide screen, so it's quite a bit larger than a typical consumer would have. And hence the need for the high gain. It wasn't hotspotting because it's curved. And when you curve a screen, you can remove all hotspotting, 100%.
There's a factor I hadn't taken into account.
So just like, it's kind of like the way a Newtonian telescope works. It's the reverse. So a Newtonian telescope, you have parallel light coming in and it gets converged to a spot, to a single focus. In this case, you have a single focus that gets diverged to a uniform brightness. So if
because the projector, of course, is acting like a point source, essentially.
That's correct, yes.
And so you really want to have the projector at the focal point of the screen curvature, right? That's
right, yep. And what happens is the screen manufacturers choose the curvature of the screen for a reason. It's not a random thing, and they pick the ones that correspond to the typical placements of projectors in a home theater.
And there are different ways to curve the screen, of course. I remember you and I talking about this offline. There's cylindrical curvature, which means that the top and bottom are straight and the sides curve inward. There's also spherical curvature, in which the top and bottom curve in and the sides curve in as well. What's the difference there?
The difference is just in how it's curved. So it either acts like a lens in two directions or in one direction.
I see.
So just the cylindrical screen works in pretty well to get rid of hotspots because the screen is shorter than it is wide. So in other words, where you have the most gain issues is along the width of the screen, especially if it's 2.35 to 1. So if you curve it in that direction, which is the horizontal direction, so making it a cylinder with respect to the audience, that gets rid of the vast majority of the hot spotting. And that's in fact what Stewart does with their curved system that they have for their 5D screen. And we would certainly recommend doing that for any high gain screen, including those for 3D. The thing about the high gain screens is once you overcome the challenges of the high gain screens, then suddenly your LED projectors, which are kind of brightness challenged right now compared to some of the lamp-based projectors, become really useful even on fairly large screens. So you have a great 2D solution, with all the advantages of the LED, the lifetime and the infinite on-off contrast, and the huge color gamut. Plus, you get the brightness that you need because you have a high-gain screen. And by the way, if you get the D73D, you also get 3D at the same time. So
I've often said that 3D is going to be a feature that sort of comes along with higher-end displays. It's going to be like online content or anything like that. It's just you buy a high-end projector or flat panel or whatever, soon, if not already, it's just going to come with 3D, and that's going to sort of be a feature.
Yeah, I think that's true. I believe it's kind of like the, back when PCs were fairly new to home users, there were all kinds of add-in cards you could get, memory upgradable, everything else, and it's not that people would use it, they just want to have the comfort of having something that could be useful to them someday. But 3D, but a lot of 3D content looks fantastic, and it's just a matter of getting it all out there so that it's not an alien thing anymore.
Right. SoCal Ray Jr. in the chat room asks, how does the light spectrum in the LED light source differ from UHP? You mentioned earlier that UHP is very spiky, which means that there are certain wavelengths of light that are a lot stronger than other wavelengths, as opposed to xenon, which is much sort of more flat and wide. How does LED compare to either of those?
LED is actually about in between the two. LED, despite people thinking of LEDs as kind of like lasers, they really have a fairly broad spectrum, and they have a great feature in the way they exist in their spectrum. So they have a dominant wavelength, and then they slowly drop down in a nice Gaussian distribution pattern to the rest. It's just like a filament at a filament of a lamp, and so it works. It's much smoother and much more predictable than a UHP lamp, for instance, a mercury lamp. The other thing, and one thing about mercury lamps is, not only is the spectrum spiky, the spectrum changes over the lifetime of the lamp.
Good point.
Especially in the red is located at the, you have a little tiny arc, and as the arc grows over its lifetime, the red is at the ends of the arc, and so the red gets more and more out of focus as the lamp gets older, so you end up getting a cyan shift or away from red of your white point as your lamp ages. Because
the arc is actually a spark, if you will, an electrical arc that goes between two electrodes that are very close to each other, and as over time those electrodes decay, and the gap between them grows wider. Is that what you're saying?
Yes, that's true. That's
okay.
Exactly what happens. That's why lamps get old, and eventually it won't be able to strike, and then you have to replace it.
Right. And certainly LEDs have the advantage of longevity. They can last, what are you speccing them at now? Tens of thousands of hours, I think, right? Yeah,
well, we've run life tests. Actually, the LEDs are warranted as long as the projector is. So we don't have a lamp door or anything like that to replace the LEDs. In our testing, we see 50,000 hours of life, and we don't. And with new technology, you always hear the hype, and the engineers try to ignore the hype to try to figure out what's really there. We ran 16 projectors continuously for life testing to get more than 30,000 hours of testing to make sure that the decay of the product was what we expected it to be, because we didn't want to take any chances that we'd have problems.
Right.
So we've done the investment, and now we're on our second LED product. So this is I'm a great fan of LEDs. Having worked with UHP since UHP was invented, I have to say that I'm a little tired of UHP. Not that there aren't great products that use it, and there aren't continuing to be developments along those lines, because UHP, actually mercury lamps, are the most efficient light source there is, period, right now. But,
more efficient than LED? That's surprising me.
Yes, more efficient, yes, more lumens per watt, absolutely, despite what LED says. But LEDs are easier to cool. LEDs they last longer. They don't drift as much. LEDs are just they're so much easier to design with. So I think it's really, especially for home theater, LEDs are going to take over.
Now you mentioned drift as well, and we were talking about UHP's the white point drifting towards cyan as the gap widens, as it decays, and there becomes less red in the image. How are the drift characteristics of LEDs over their entire lifetime?
Well, LEDs do dim over time. They also dim over temperature. So what we do is we have an automatic, essentially, calibration that occurs when the projector is turned on. Every time the projector is turned on, and every time you change color temperature as well, it does a color balance calculation, and we have an internal tri-stimulus sensor to make sure that the white point doesn't drift at all. Now,
so it's calibrating itself regularly, all the time, basically.
Yes, the major calibration occurs at startup, and then it continuously monitors the brightness of the three colors all the time. It's actually every single frame. It's monitoring, and it builds a little histogram over time, and then decides what to do, and it varies. We aren't running the LEDs at full power because we need to have the extra headroom allowed to do the loop required to self-calibrate continuously. So we don't necessarily have the brightest LED projector out there, but I bet we have the most uniform LED projector out there.
And uniform over time, yeah.
Yeah.
I assume, of course, a buyer can hire a calibrator, or if they know what they're doing, do it themselves and actually calibrate the projector themselves, right?
Yeah, sure they can. They just have to be careful that they don't use a tri-stimulus colorimeter that was designed for a mercury lamp, because it's likely that they'll run into trouble if they do.
Of course, because the tri-stimulus colorimeter, which in fact only senses red, green, and blue at particular wavelengths, if those red, green, and blue wavelengths are not where it expects them to be, it's going to give you a poor result.
Yes, and it will give you a visibly poor result. So you will know immediately that it's wrong just by your eye. Your eye is way better than most color meters at detecting whether white is bad or not.
Sure.
Especially if you've seen a lot of images over time, as a lot of the professional calibrators have.
Sure.
But yeah, I mean, there are a number of new tables that you can get to make sure that your meter works with LEDs. It's not that they can't work; they just need to have a LED calibration curve associated with them.
Yes, an offset.
Right.
A mathematical offset to compensate for the fact that they're looking for a certain red, green, and blue, and what they're seeing is a different red, green, and blue.
Exactly.
Yeah. Okay. Beatmaster in the chat room asks, doesn't stacking allow full resolution per eye? Clearly it does, right?
Clearly, but so does frame sequential or the shutter glasses.
Right.
But it does, and it also allows full bit depth per eye as well. And that is one of those things that, especially with DLP, DLP is a pulse width modulated device. In other words, in order to create 50% gray, you have to have the pixel on for half the time and the pixel off for half the time. And then as you cut it up, say 10% gray, you have to have the pixel on for 10% of the time, this is 100% on, and then off for 90% of the time. And as you continue to slice that up, the so-called bit slicing, you end up with a total bit depth of your product. And DLP is really only barely acceptable to me for home theater at 60 hertz. Once you go to 120 hertz, your bit depth has to drop because suddenly you have 1/2 the time to create your grayscale. So, or actually slightly less than that because there's a dark time as well that has to be put in there to compensate for the fact that the glasses don't switch instantaneously.
Right. So there's a black frame insertion between each time the glasses flip.
So what you end up with is an image that has less bits, a less bit depth than you would really want. And to me, it bothers me when I see it with 120 hertz systems. Not that it's necessarily an awful thing. It's one of those things you just got to be aware of. Your bit depth will drop by at least 1 bit when you go to 120 hertz. So what you start seeing is when things pan, you'll start seeing contouring in things that move.
Mm-hmm.
It's what we've called in the industry temporal contouring, and it's associated with the fact that in order to make the grayscales appear to be smooth, DLP has to dither to do that at low brightness levels, just like plasma does as well.
Sure, and dithering is basically adding randomness or random noise to the signal in order to mask this problem.
Yeah, it uses a blue noise algorithm, which is a typical dithering algorithm that's used in still photography. The thing about the dithering becomes apparent when things move, though. So as things move across the screen, the dithering really can't keep up what it comes down to, and you start seeing the base contouring of the image. You start seeing the native bit depth of the image if things move. Mm-hmm. And you will know. And so one thing, if you're a real video file and you look at a continuous system like the D73D versus a 120 hertz system, everything else being equal, you will see far more contouring, or banding as some people call it, on the 120 hertz system when it's running at 120 hertz.
Right. And in particular in 3D mode, when you are seeing only 60 hertz per eye, and therefore, as you say, a lower bit depth per eye.
That's right.
This is also true of plasma and LCD flat panels? Because they are all active glasses.
It's true of plasma because plasma also pulse width modulates. For LCD, I think the artifacts are different. I think that there's the switch on, switch off time that you start running into with LCD. Mm-hmm. So it doesn't really shut off completely. It can't really change the pixel entirely at 120 hertz. It maybe can go most of the way, but it can't go all the way, and you see that as ghosting.
Which is why a lot of LCDs have black frame insertion built in as well.
Yeah, you got black frame insertion, and you also change the duty cycle of your glasses in order to compensate so that you don't, so that you actually put up black for a small period of time. And
where both lenses are closed for that brief period of time.
And some of that may have to do with the fact that there aren't standard glasses out there. Generally aren't, at least not for the LCDs of the world. And it might
this is a big bugaboo for me. I just hate it that they came to market with 3D and did not standardize the glasses.
Yeah. I don't know. It's one of those things where it's hard for manufacturers to get together if they're going to be competitive with one another. It's almost like you need a standards committee to do it for you, to shove it down your throats.
Yeah, I know that that's certainly a factor, but taking an example from my previous life as a journalist in the pro audio world, I look at MIDI, the musical instrument digital interface, and all the manufacturers who were deathly competitors to each other. I mean, they wanted to kill each other. They wanted to see each other die. But they sent all their engineers into one room and said, we've got to come up with a system that will allow all of our products to talk to one another. And they did. And almost 30 years later, MIDI is still functioning, and it didn't, it rising tide floats all boats, right? And it did exactly that. So why can't the consumer electronics manufacturers learn from history, for God's sake?
It's a very good question. I don't know. They're in lots of different countries. They have very low profit margins these days.
Well, that's true.
I really don't know. And all I can say is that our 120 hertz systems, which we do offer on our very high end projectors, are compatible with multiple shutter glass technologies. We can use the expand and some of the other ones that are out there as well. We aren't stuck with one.
So, but you achieve full resolution in both eyes differently by having the two separate projectors in the case of the D73D.
Yes, they are continuous, so both eyes are on all the time. And that means that you end up with no flicker. So that's one of the other issues with 120 hertz, is that there is a significant portion of the population that will see flicker even at that speed, because you have two 60 hertz streams that are only 50% duty cycle, that in other words are black half the time. So, and when they're out of phase with your eyes, they're 180 degrees out of phase for each eye. So the flicker fusion frequency is above 120 hertz for many people. And that's why Real D chose to go with 144 hertz for the movie theaters. You know, they triple flash the 24 hertz in order to try to get to a level that's high enough so that most people would be fine with the flicker. They also have very good image.
In other words, they wouldn't see the flicker. They wouldn't be aware of it.
That's right. Yeah.
I was going to mention Real D in the theater, which achieves full resolution in both eyes by quickly alternating the polarization of the image coming off the projector. So it'll flash the right eye polarization and then the left eye polarization and then the right and then the left and the right and the left at 144 hertz, as you say.
Right.
Which gives us full resolution in each eye from a single projector.
Yes, it does. And it's that polarization switch, and that's one of the reasons that they're circular polarized for that system, is because the switch relies on the fact that it's circularly polarized. So it would be hard to make one that works with linear polarization.
I didn't realize that. I was curious to know why they use circular polarization. And we should say, by the way, to those that might not understand this, we were talking earlier about linear polarization, which is vertical or horizontal. Circularly polarized light is even stranger. And it's
just
probably
a different coordinate system.
It's a different coordinate system, but basically the light waves actually corkscrew through space. And they either corkscrew in a right-handed manner or a left-handed manner, or clockwise or counterclockwise, however you want to talk about it. And that's what Real D uses. So when you go out to the cinema to see 3D, you're going to see circularly polarized light, as opposed to the Runco system and actually IMAX 3D, which does use stacked projectors, and they use linear polarization.
Yeah, in fact, what kind of inspired me to even venture down the path of linear polarization was after I saw Avatar at both a Real D cinema and at an IMAX 3D cinema, and I greatly enjoyed the IMAX one better because I'm very flicker sensitive.
There you go. So again, it's then that's a sort of an individual issue, which can also relate to, are you particularly sensitive to DLP rainbows, for example? Because some are more and some people are more sensitive, some are less.
Yes, I am, and I've been an advocate of getting the color refresh rate as high as humanly possible. So on the D73D, which is a single chip DLP, but it has no color wheel, it has an equivalent color wheel speed of 20x, or 20 times. So each color refresh is 20 times per frame. That's something
the most common color wheel frame rate or refresh rate is like 6 times, right?
6 times is the most common, yes. Although for business projectors, you get down to 3 times sometimes. So,
right, but with business projectors, it sort of doesn't matter.
Yeah, well, some enthusiasts think that they can get away with using business projectors for home theater, and and I'm all for trying out stuff and seeing what's out there and educating, by fire, I guess. But truth is that business projectors produce really poor home theater images in general.
Yeah. Now, the disadvantage of linear polarization is that if you tilt your head, you start getting crosstalk, which
That's
is
right.
you start your right eye starts seeing the left image and vice versa. So doesn't that mean you have to kind of hold your head in a vice?
Well, you actually, what happens is your head actually naturally goes to a position where the crosstalk is least because you're kind of training yourself. The thing that's that, IMAX uses linear polarizers, and they don't get a whole lot of complaints about ghosting, and they don't tell people to keep their heads at horizontally. The truth is, linear polarizers are more efficient, or have better crosstalk performance than circular, up until about 5 degrees of tilt. So if you're holding your head less than 5 degrees, and generally you are because your eyes are pretty horizon sensitive, then you'll get a higher eye-to-eye contrast with a linear polarizer than you will with a circular polarizer. Now, all that being said, we understand that some people enjoy the idea of tilting their head, even though the other thing about it is the 3D itself was designed for a left eye and a right eye, not eyes that are oriented at an angle. So you're going
True
to start.
enough.
What happens is when your brain tries to fuse together two images that are right and left, but you tilt your head, then your eyes start moving up and down in order to compensate. And your eyes really don't like doing that very much. So, even with circular polarization, you will start to get a pretty big headache if you tilt your head, even though the ghosting does not go up.
Right. This is very fascinating because LG just recently announced that they are going to start offering polarized filters for their LCD 3D TVs, and they're advertising it with a guy lying on a couch, basically lying horizontal and saying, see, you can watch 3D TV while lying on your couch.
I don't think that's a good idea.
From what you're saying, it sounds like it, yeah.
Yeah, but so, regarding the circular polarization, we will allow people to use circular polarizers if they want to, and we can certainly there will be it's slightly more expensive to provide them with our products, but we will certainly be able to and who wants them, they can certainly get them. We aren't preventing that. We will have an option for that.
I was actually thinking about bringing my Real D glasses up when I visit you guys tomorrow and Wednesday, but I guess there's no real reason to do that, is there?
We might be able to. Well, yeah, I don't think so right now. Wouldn't be a good idea. All our glasses that we're currently using in engineering are linear.
Right. That's fine. It's totally fine. That reminds me, though, that I want to tell everybody that I will be visiting Runco, which is located in Beaverton, Oregon, tomorrow and Wednesday to take an actual close-up look at the D73D myself, and we'll certainly be writing about that on ultimateavmag.com, so be looking for that later in the week.
So can I go back to the frame sequential thing again one more time?
Sorry?
So one more issue with frame sequential 3D.
Oh, please. Go right ahead.
So you know how I talked about seeing Avatar in both Real D and in IMAX 3D. One thing that I noticed quite strongly, the biggest difference that I saw was the fact that there were more motion artifacts with the Real D system. And I think
such as, you mean like stuttering or blurring, or what do you mean specifically?
So stuttering, essentially, it looked like when things were moving, they would do this. They would have a very stuttered appearance to them. I think it has to do with the triple flash that they do. Mm-hmm. So they're essentially...
I've noticed that in particular, things that are supposed to be in the far foreground that are closer to you.
Sure. But with the D73D, with what we call constant stereo vision, we show it at 24 hertz. We don't have to step every other frame at 144 hertz in order to show you moving images to prevent flicker. So we actually, if it's a 24 hertz source, we will give it to you at 24 hertz. And so you shouldn't see any motion artifacts associated with that.
You don't project each frame more than once? I mean,
Just
even a 2D movie theater will show each frame 2 or 3 times, a double or triple flash.
Not these days. Not for DLP.
Really?
24 hertz. Yep, 24 hertz is what you see.
Not 48 or 72 or 96, huh?
Nope. The only reason you need to do that is because of the 50% duty cycle of film projectors. But DLP is 100% duty cycle. In other words, it's, if you're just showing a static image, it's 0 hertz. It's 0 frames per second. And
True.
so you don't need to, there's no flicker issue with showing things at a low frame rate. The only issue is the standard problem of 24 hertz in general, the fact that motion can appear strange if you pan quickly. And that's what cinematographers and camera people have been dealing with for a long time now.
But you're saying that when I go to see a digital presentation of a 2D movie, which actually I did last night, went and saw Rango, that I'm seeing actually 24 frames per second.
Yes, you are.
Wow. Huh. Now, certainly if you get the frame rate down below a certain level, you're going to start seeing it appear to be a series of still images moving quickly.
That's correct. And that's the whole reason why it shot at 24 hertz in the first place. It's kind of like the lowest frame rate you can have to effectively show motion. But that's
smooth
just,
motion.
Right. So, yeah. So with digital cinema, the whole double flash phenomena is now gone. It hasn't existed. I mean, if you see a film on a real film projector, it will double flash because it'll be 48 hertz at 50% duty cycle in order to prevent apparent flicker. But if it's a digital presentation, it will be 24 hertz, 100% duty cycle.
And duty cycle, by the way, just for those who don't know, is the percentage of time that the image is on the screen versus the percentage of time the image is not on the screen and the screen is black. That's right. Wow. Well, you learn something new every day. I thought digital still double and triple flashed, but
Nope.
But you're telling me it doesn't. That's amazing.
Hey, it's just that's one of those technology things. It's kind of like it's like LCD monitors now can run at 24 hertz if you want them to, and they won't flicker. So once you've gone away from the phosphor decay of CRTs, then you can, whenever you have a continuous display, then the frame rate really actually kind of becomes variable. You can use whatever you want, and you won't see any flicker.
Now, this is very interesting because it brings up something that's peripheral, but pardon me if I go off on a tangent here a little bit. I was talking with a plasma guy about the difference between 120 hertz LCD, or 240 hertz LCD for that matter, and 600 hertz plasma, and how those two things are really apples and oranges, and you can't really compare them. But what he was saying was an LCD keeps the image on the screen for the entire 60th of a second, or 120th of a second, or 240th of a second, and the problem with a 60th of a second anyway is that if something is moving, your eye is going to continuously sweep to where it expects that to be, but it's not going to be there because it's frozen for a 60th of a second, which is how you get motion blur, as opposed to plasma, which, as you said, uses pulse width modulation and basically flashes the image many times in microsecond intervals rather than millisecond intervals, and that gives your eye a better sense of where it is, and which is why it's sharper. Now, do you agree with that analysis?
Well, the basic idea of having higher frequencies and more frames certainly would create less motion problems. So, if you show what's taken with a film camera, let's say with a 50% duty cycle shutter, in other words, 50% of the time it's on and 50% of the time it's off, and you project that the same way that you shot it, then it will look exactly the same as the way you shot it. I mean, the way it was supposed to look. If you show it at 100% duty cycle, like on a DLP or on an LCD, then it may look a little strange because you get less of that strobe effect, and the position is not correct as you're moving across the frame. So to that extent that statement was correct. The thing about 600 hertz plasma is that still the frame rate is 60 hertz, so it doesn't help. The 600 hertz is really kind of like saying, DLP is 10,000 hertz. And, because every mirror can move at, 1/10,000th of a second. But that doesn't, it's the base frame rate that you need to compare. It's not the actual highest frequency you can create with each pixel.
That's a good point. Frame rate is the same in both cases.
If it's the same, then you'll have the same motion artifact, unless you strobe. So you can have dark time. If you put dark time between when you show the images, then you create more of a strobe effect, and you create and you have a better, less blurring of the image when you do that. And depending on how it was shot, that might be appropriate. If it wasn't shot that way, then it may not be appropriate, because if you're shooting it at 60 hertz and you have 100% shutter, let's say on a CMOS camera, for instance, then if you display it 100% duty cycle, it will look exactly the same as the way you shot it. So it all depends on how you want, on how it was mastered in the first place, whether that's appropriate. So some of our higher end DLP projectors have an ability to add dark time in between frames in order to make images look better when they're moving. Typically, that's only done for, it's not done for movies, it's done for like simulation and things like that. It's really done in the context of where people, may get sick because of the blur or things like that. In movies, generally, they're shot so that they don't make you sick. So they already know what to do to make the image palatable.
Most movie cameras shoot at 100% duty cycle or 50%?
Can. Generally, they don't. So, I think one of the first big movies that came out that was shot in video, well, actually after Star Wars, was Apocalypto. And there were some scenes that were shot with a large dark time between images to create kind of almost a sports type strobe effect. But other scenes were shot with much closer to 100%. So it all depends on what you're looking for in the way, And of course, in order to figure out what you're looking for, you have to know how things are going to be projected as well. So,
which you can't know altogether because, your movie's going to be in some film theaters, some digital theaters, and so on.
Yeah, I suppose whatever they use for their dailies is what they ended up figuring out what they wanted to optimize for. So these days, it's often a digital projector.
Yes. Beatmaster asks in the chat room, aren't three-chip projectors the way to go? You mentioned that the D73D is a single chip with LEDs flashing much faster than color wheels, but couldn't you do even better with three separate chips, one for red, one for green, and one for blue?
You could. LEDs don't scale that well when you go to 100% brightness. So LEDs actually like to flash. They're more efficient when they're flashing than when they're full on. So if you were to create a 3-chip projector with LEDs, it would not be twice as bright or 3 times as bright as a single chip projector with LEDs. It would be a little bit brighter, and you would also get the other good things that you get with having 3 chips. It's kind of like, we have two eyes continuously on. When you have 3 chips, you get 3 chips continuously on. So you get even more bit depth potential there, and you get a smoother image with the least amount of dithering per frame. Now, when you have 3 chips, you have the issue of convergence all of a sudden. So with single chip, you have no convergence issues, unless you have 2 projectors, I guess.
And we didn't talk about that, actually. And maybe that should be one of our last topics here at the end of the hour.
Okay.
Is converging those 2 projectors. They've got to be pretty precisely converged. How do you go about doing that?
Well, that was one of the biggest issues that we had going into this project. We thought, well, do we have to, spec some ultra-low distortion projection lenses on this product in order to actually make it work? Well, the answer was no. What we did instead is we provide a warp algorithm, a 9-point image warp system that actually that allows you to adjust one projector to match the other projector. You can grossly align the images with your basic optical controls, your focus, zoom, horizontal and vertical offset controls. And then to get the last couple of pixels, or the last pixel or so, you use a warp algorithm and we only warp one image. It's the right eye image, which is usually the image that's the lower bandwidth image on a 3D Blu-ray anyway.
Mm-hmm.
And you warp it to match, and you end up within a half a pixel of the other projector, and so you don't see any problems at all, even at the largest offsets, or even when we use anamorphic. We have a stacked projector system that can use anamorphic lenses. Nobody else can do that, and the only way you can get away with doing it is by having a really good warping algorithm in order to compensate for the two different lenses.
So in fact, I did see this at CD, I believe, where you move the anamorphic lenses in front of the primary lenses. You can show a 235 or 240 image on an appropriate screen of that aspect ratio without seeing any black bars. And what you're saying is with the warping algorithm, you can align them so precisely that even doing that, even passing them through that much optics, things look nice and sharp.
That's correct, and it looks fantastic. And it's just one of those things that on top of all these different little steps we made in this project, we end up with this package that works really well, and it's very easy to set up, and we're quite proud of it, actually. So,
and I sure look forward to seeing it on Wednesday, when I'll be able to actually spend several hours looking at 3D material and some test patterns, and you have some test equipment up there, so I'll be able to actually do some measurements and see how close to the proper color gamut. That's always one thing I worry about, speaking of which, color gamut. You said that LEDs have a really wide color gamut, and that's all well and good, except that all the content we have is mastered and created for a particular color gamut. So if a projector or a display device can display a wider one, that is more colors than the content has, that's a red flag to me, because I want to make sure it can come down to the color gamut that it needs to in order to reproduce the content accurately.
Right, and that was also a big concern of mine when we first started the LED project at the very beginning, 2.5 years ago. So what we have in our system is a 6-axis CMS that you can adjust the color points and the color brightness for 6 different colors and your white in order so that you can end up with as good a calibrated system as you want. Now, I will say, though, that even we have a special setting called Runco Native, which uses the full gamut and changes the way the hues are shown to compensate for the sunburn look and things like that. It makes flesh tones, it brings them back to what they would be under Rec 709. But it also allows you to have the really bright colors for like sports, for daytime activities that you knew were there to start out with. And the camera person and the broadcasters wanted to show you those colors, but they couldn't. And so we have that mode that allows you to see them.
So you're reading the minds of the broadcasters and the content providers and the cameraman, huh?
I just know what things look like outside. And they don't look like the muted, especially that red, that Rec 709 red, that exists with our standards. It can be calibrated as a perfect Rec 709 monitor too, if you want. So there's no downside to having the larger gamut.
Great, wonderful. Well, I'm sure looking forward to seeing it and to seeing you on Wednesday. Meanwhile, I want to thank you, Bob Williams, for being my guest geek on today's show. Fascinating stuff. Thanks so much.
Thank you. It's been an honor.
My pleasure. To read more about Runco, the Runco D73D and other Runco products, simply go to runco.com. My online homes are ultimateavmag.com, hometheatermag.com, actually hometheater.com now. We just changed that URL. You can email me at scott@twit.tv and follow me on Twitter at htgeekscott. Next week, my guest geek is scheduled to be Jerry Mahabub, CEO of Gen Audio and the inventor of Astound Sound 3D audio technology. Now, this is a really cool 3D simulation technology, so I sure hope you will tune in at that time. Until then, geek out.